So now that we've learned about how to justify arguments or validate our own arguments in, just in life in math class, what we're going to do is construct an algebraic proof, which is just an argument, but you're able to actually back up what you're doing and why you're doing it. So we're going to write some proofs and we'll use those properties, algebraic properties, to justify the steps in the proof. So let's go ahead and just look at these properties right here. So these you have to have memorized. However, because it's a crazy amount of stuff to write, and I want to make sure that you have them correct, I am going to print this out and give it to you in class. So you will not have to worry about getting these written down in your notebooks. You'll just have it ready to go once you come into class, and then you can use it as a reference sheet. So hopefully you all are listening, because if you're not, then you'll copy this down, and that to me is going to be entertaining. Anyway, so let's go ahead and write some proofs, and I'm just going to do two of them. They're pretty short and sweet. There's not a whole lot to it. They can be a little bit frustrating, but if you just work with it and have the properties in front of you, it'll make more sense. So for now, obviously you're not going to have the properties right here in front of you, but when you get into class you will, and so we'll be able to kind of look at these again together and see why things work the way they work. So when you're constructing a proof, you're going to have two columns, so statements in the left column and then reasons in the right column. And so then what you're going to do is you're always going to start with step one being your given statement, so 2x plus 1 equals 8x minus 5. And so your first reason always going to be that it's given to you. And that's like the easiest part of all of it. All right, so then from here, what would we do in order to solve this and find out that x is equal to 1? Well, let's say we subtract 2x from both sides of our equation, okay? So we end up with step 2 being 1 equals 6x minus 5. So the question that we ask ourselves, and the way that we get this reason, and I'll write this here, is how did we get this? So if I covered this up, if I were to erase everything that I wrote and only had these steps right here, the question is, how in the world did I get from step 1 down to step 2? Well, the way that we were able to do that was by using the subtraction property. So subtraction property of equality. Okay, so now what would your next step be? Well, we're trying to isolate the variable, so add 5 to both sides of the equation. So here's number 3 would be 6 equals 6x. So again, how did we get this? Okay, so pretending like this is not here, if all I had was step 2 and then step 3, how did we get from step 2 to step 3? And the way that we were able to do that was by adding 5 to both sides. So since we added 5, this is the addition property of equality. All right. Now our next step would be to get x totally by itself. So we would divide by 6 on both sides. So here's step 4, which would give you 1 equals x. All right, so now yet again, how did we get to the 1 equals x? We got there because we divided by 6. So this is your division property of equality. Okay, and then moving down, just one last step, and the only reason we have this last step is because if you look at the original, it says to prove x equals 1, and so right now we have 1 equals x, which isn't identical, so we're going to flip it and make it x equals 1, and that property is called the symmetric property. So flipping something in that manner is the symmetric property of equality. So there you go. We're just backing everything up. And so generally what it's going to look like is getting rid of these steps and not having them there for you to actually look at and being able to analyze how each step was formed. Okay, so the work in between you don't justify, it's just each step. How did you get it? Here's how I got it. How did you get it? Here's how I got it. Okay, so let's just do one more. And the reason I'm introducing this one is because of the fraction and you kind of freak out about it, but I have a really easy way to get rid of those fractions. So same as in the last one, we start with our given. So 1/5 x plus 3 equals 2x minus 24. And our reason is it's given. Okay, so let's get rid of this fraction and all this craziness. Well, if I decide to take all of this and multiply it by 5, and I take all of this and multiply it by 5, which I get from right here, okay, from the fact that it's the denominator, if I do that, I would distribute the 5 to 1/5, which gives me 1x, 5 to the 3, which gives me 15, equals 5 times 2x is 10x, and 5 times 24 is a negative 120. All right, so in that second step, or for your reasons, now how did we get that? So we got this because we multiplied by 5. So multiplication property of equality. All right, now in your next step, we're going to go through the same process of just solving equations because we got rid of our fractions. So for step 3, we have 15 equals 9x minus 120. And how did we get that? We got that because we subtracted. So subtraction property of equality. All right, now our next step, we would add 120 to both sides of our equation. Oops, add 120. Okay, and remember we don't justify that step, we justify what happens after we add. So we get 135 equals 9x. We got this because we were able to use the addition property of equality. Okay, the next step would be to isolate the x completely by moving the 9. So we would divide by 9 on both sides to give us 15 equals x. And so for that, we got this because we divided by 9. So division property of equality. And then in our sixth step, remember you want this to match, so we're going to flip it to make it x equals 15. So in step 6, we got that because we used the symmetric property. Whoops, there we go, of equality. Okay, so again, to remember that your end result right here needs to be identical to what you are trying to prove. Your first step that's given to you here is always your given, so that is always that way. And then what you do is you work with each one and you justify how did I get what I got, or how did I get to this step, and that's how you come up with your different properties to put in your second column. Okay, so when you come into class, I'll have the property sheet for you to kind of help you see how this works, and then we'll do some practice with it.